We are going to be continuing with simplifying our rational expressions. There's a few things that we want to verify that we do as we go through this process. First thing we want to do is factor everything, every part as much as possible. That means we need to check for all of our different ways to factor. We need to check for a GCF. We need to factor our trinomials into binomials. So if we have ax squared plus bx plus c, we need to turn that into x plus a number and x plus a number. We need to cancel out expressions that are equivalent, not individual terms. So we have to be very cautious of this. Sometimes we accidentally cancel out a variable where we're not allowed to cancel out a variable or a number, etc. And then we want to check that our final answer is fully simplified. So if we have anything reduced or anything to cancel out, we want to make sure that all of that has been done. So for our first example here, we are going to factor the numerator, which is the top of our fraction. It is currently a trinomial, so we want to turn that into two binomials. And then on the bottom, we also have a binomial that says x squared minus 4, and that is going to be a difference of squares, so we're going to be able to factor that as well. So to factor the top part, I'm going to do this over onto the far side here. We are factoring x squared plus 7x plus 10. Now we are going to look for terms that multiply together to be 10 and add together to be 7. So this may help to make a factor tree or some sort of list. So things that multiply together to be 10, so factors of 10 that have a sum equal to 7. So factors of 10, thankfully, there's not a long list here. We've got 1 times 10 and 2 times 5. Both of those are going to equal 10. So we have to think about, well, which ones add to equal 7? 1 plus 10 equals 11. That won't work. But 2 plus 5 does, in fact, equal 7. So that is the one that we want. So when we factor x squared plus 7x plus 10, that's going to turn into x plus 2 and x plus 5 when we take those two factors, 2 and 5, into consideration. Now on the bottom, we have x squared minus 4. When we see that 4 is a perfect square and x squared is also considered a perfect square, we can break this down into x minus 2 and x plus 2. So x minus 2 on the bottom, x plus 2 on the bottom as well. Now the x plus 2's exist in both the top and bottom, so those are going to cancel out. That's what I mean when we cancel out expressions, not individual terms. I'm not crossing out x individually. I'm not crossing out 2 individually. I'm crossing out the entire expression x plus 2 together. So both of those cancel out, and we are left with x plus 5 over x minus 2 on the bottom. Now, you can leave these in parentheses, or you can leave them without parentheses. I cannot just cancel out the x's because they are tied together with the 5 and the 2 by addition and subtraction. So those are not something that you can easily cancel out. You're just going to leave it as this. This is your final simplified expression. So let's look at a second example. This one we may need to take out greatest common factor, or you may need to factor the trinomial. It looks like we have a little bit of both. So I'm going to need to factor out on the top, the numerator. I have 2x squared plus 6x. I believe I can take out a greatest common factor. So we're going to look at what we could divide out. The greatest common factor between 2 and 6 is going to be 2. It's the largest number I can divide out from both. And then both terms have an x. So I'm going to take an x out as well. So we're going to imagine that I'm dividing 2x squared plus 6x by 2x. 2 divided by 2 leaves us with 1. So if you want to put a 1 there, you can. You don't have to. X squared, or x to the power of 2, divided by an x leaves us with x. 6 divided by 2 is 3, and x divided by x leaves us with no additional variable. So you can say 2x parentheses 1x plus 3, or you could say 2x x plus 3. This would be the most standard version of that. If the 1 isn't doing anything, we can just remove it. Now on the bottom, we have 2x squared plus 7x plus 3. So this is a trinomial we're going to have to turn into two binomials. And it is a trinomial that has a leading coefficient of 2. So we are going to, in fact, multiply the a and c, the 2 and the 3, together, and that gives us 6. So we are going to look for factors of 6 that have a sum of the middle number, which is 7. Factors of 6, there are not a lot of options. You've got 2 times 3, which is 6, and 1 times 6, which is also equal to 6. 2 plus 3 would give you 5, and 1 plus 6 would give you 7, which is what we want. So that means that 1 and 6 are going to be our two factors. Now, since the leading coefficient is not 1, it is in fact 2, we are going to have to factor this a little bit more. You can either use the reverse box method to do so, or you can go ahead and turn it into two binomials and then factor out a GCF if possible, or divide out a GCF if possible. If you use the reverse box method, I'm going to draw myself a little box. And I'm going to put a, which was 2x squared, in the top left corner. And in the bottom right corner, I'm going to put c, which is 3. And then our terms are going to be 1x and 6x. That's going to fill the remaining boxes. And then I am going to factor out a GCF from each row and column. So if I look at this first column, I have 2 and 6, and the greatest common factor between 2 and 6 is going to be 2. And then we have x squared and x, and the most I can take from both equally would be one single x. So for that column, my GCF is going to be 2x. I'm going to do the same for the right column. For 1 and 3, the greatest common factor is just going to be 1. And I don't have an x in both terms, so I'm going to leave it as is. And since all of these numbers are positive, I'm going to put a plus sign in the middle. Now I'm going to factor out the GCF from the top row. 2 and 1 has a greatest common factor of 1. And then we have x squared and a singular x. I can factor out or divide out 1x. Now the 1 at the front of that doesn't do anything, so I took the 1 away. And then in the bottom row, the greatest common factor between 6 and 3, the largest number that divides those two, is 3. And we don't have two x's, so I'm going to leave it as is and put a plus sign in between. So this turns into 2x plus 1 times x plus 3 as our factored piece on the bottom. So I'm going to add that to the bottom of my expression. And if you look and see, we have an x plus 3 in parentheses on the top and an x plus 3 in parentheses on the bottom. So those two terms, those two expressions, will cancel out, and we'll be left with 2x on top over 2x plus 1. Now, I'm going to leave those parentheses around the 2x plus 1 because we have to remember that 2x is being added to the 1. They're tied together with that plus sign, that addition. So I cannot cancel out the 2x on top with the 2x on the bottom. That would not be an accurate next step. So this problem is done. My final answer is 2x over 2x plus 1.